In chapter 11.3, we're going to continue forward using our nets, our three-dimensional shapes, this triangle effect, which is going to allow us to figure out the area of our surface area of a prism. The only time that's not going to work is if our bases are triangles. That throws off our entire aspect of the prism. So once again, a prism is a closed-in shape that's not a pyramid. So what that says is all the opposite sides are parallel. So the bottom and the top are parallel, front and the back are parallel. The right and the left are always parallel. For the pyramid, I have all the sides, but they come up to a point. So I don't actually have a top. When I look at the shapes we're talking about, this is like a rectangular prism. So the way the book is going to have you do it is finding all of the different areas and then adding those surface areas together. Well, if I look at the shapes that are the same, if I start just out here at the end, then I know 1 and 2 are going to be the same. And I'm going to have 2 of the same, unless once again it's a triangular prism where the bases are triangles. And I have to figure out what the base is and what the height is. So I know I'm going to have 15 and 10, and when I multiply those together I get 150. The two that are alike with the 12 and 15 then, I would multiply 12 times 15, which is base times height. I'd get 180 for this one and 180 for this one. So then I'm left with A and F, which are the same. And I would use the measurements of 10 and 20. So I know I have, once again, 2 of those. I would take my base times my height. 10 times 12 is 120. So that one has to be 120. And I'd add those all again together. I really and truly believe that this triangle is going to help you do it easier and in fewer steps. Fewer steps means less mistakes with my accurate math. So if I just list the 3 measurements that I know I have, and it's given to me up here what I have 15 by 12 by 10, and it doesn't matter which number goes where. As long as you set them up in the shape of a pyramid or a triangle, and then I loop them together and do the math. So once again, I just take the bottom 2, I loop them. I know I'm going to take the side 1 and side 2. I'm going to multiply them together, which is base times height. And there's always 2 of them, unless it's a triangular pyramid. And I multiply it by 2. So I take 150 times 2. And then I take these 2 sides. Here I have 15 and 12. 15 and 12, handy dandy calculator, type it in, equals 180. And I know I'd have 2 of those. And then I'm left with the 12 and 10. 12 times 10 is 120. And I know I'd have 2 of those. So when I do it, and I multiply each of those by 2, I get 240, 360, 300. When I take all of these and add them together, if I just group the ones that are together, the 150 and 150, that's where the 300 comes from. The 180 and the 180, that's where the 360 comes from. The 120 and 120, that's where the 240 comes from. So this is just more steps that I have to do compared to the triangle. Either way, I'm going to get 900 square inches. And once again, labels on areas, even when it's surface area, because I'm taking a total of areas, is always going to be squared. The triangular prism is different. In the triangular prism, I have to just figure out what the side measurements are and figure out the shapes. So on this one, it says, if this is my triangular prism, so notice that the faces, the top and the bottom, are indeed triangles. It's not a right triangle, it's not an equilateral triangle. So that means all of these 3 sides, the B, the C, and the D, the rectangular faces, are all going to be different measurements. So I just have more math I have to do. It's not difficult math. It's basic multiplication, and some of it will have multiplication with a fraction, but we've been multiplying since 4th grade. We've been multiplying with fractions since 5th grade and at the beginning of this year. So this is not difficult math. It's just several steps that you have to remember to do in order to find the surface area of this geometric shape. So if I take my bases, which are my triangles, I know it's going to be 1/2 times base times height. Once again, I prefer base times height divided by 2. Same math, same formula. So if I take my formula and I look at what my triangles are, then I know I have a base of 5 and a height of 5 and a base of 12. So when I multiply those together, I have my 12 times my 5. They have the 1/2 out here. I have my 60 over 2, because 12 times 5 is 60. Multiplying by 1/2 is just simply dividing by 2. I still get to that same point if I use my fraction of 1/2. That's why I always just start with the division by 2. And then when I reduce that, I have 30. But once again, it is a prism, and I have 2 of them, so I have to just go back and multiply it by 2 then, and I'm going to know that I have 60. When I have my B, when I look at B, I'm looking at 5 and 10 for my measurements, and 5 times 10 is 50. When I go to C, base times height once again, or excuse me, C, then I have 12, and it still has a height of 10. All of these are going to have heights of 10 because of this last measurement right here. So 12 times 10 gives me 120 for C. And then D tells me that I have 13 times 10. And 13 times 10 is 130. So going back to my surface area of my triangle, it's a reminder that on the surface area I have 2 of those that make it up. So 2 times 30 is going to be 60. So that's what this multiplication of 2 is. So I'm going to just cross that out and put 60, so the rest of it is just straightforward addition. But I have my 60 for my 2 triangles, and then I have my 50 for rectangle B, I have my 120 for rectangle C, I have my 130 for rectangle D. I add those all together, I get 360. Not asking you to do mental math. Handy dandy calculator, type it in, equals, I get 360. And then because it is surface area, and I'm finding area, my label, once again, is always squared. On this one, I have a cube. So my cube, there's 3 different ways I can solve this problem. You do what you're going to be successful at. We'll do what the book does. We'll do the triangle, which is what I do, and then they'll show you a second way that the book would introduce it. When I have a cube, I know that it's a square on every single face, and that there are 6 faces, right? Because a cube has a front and a back, a top and a bottom, a right and a left. So I know there are 6 faces. But every edge, once again, edge is like a capital E, straight lines. Every edge has the same measurement. It's 5. So if I know that's true, then to find the area of the front square, I take 5 times 5. And 5 times 5 is 25. Well, then I find the sum of the areas of all the faces. Well, if the front is 25, then the back is 25. That's 2. The top is 25. The bottom is 25. That's 4. The right is 25. The left is 25. That's 6. So I'd have 25 plus 25 plus 25, 25, 25, 25. Every one of those faces is going to be 25 square centimeters. There are 6 faces. I have all 6 written down. I add those together. I get 150. If I do the triangle, it's still going to equal the same thing. I put my 5s, 5s, and 5s. I multiply them by sets, and then I always double it. So 5 times 5 is 25 times 2 is going to be 50. 5 times 5 is 25 times 2. It's going to be 50. 5 times 5 is 25 times 2 is going to be 50. 50 plus 50 plus 50 gives me 150. They're also letting you know that, well, if it is a square, then all I have to do is square my side. So 5 squared. Once again, the square doesn't tell me to multiply by 2. It tells me to multiply that number by itself that many times. So 5 times 5 is 25. And if I take 25 times 6, I get 150. I'm always going to get 150 square centimeters, no matter which of the 3 ways I do it, as long as I do the math correctly. Excuse me for a second. So when I go over to my practice problems then, I see that they're starting with a cube. Now when they set it up for you, you have to be able to fill in the information. You may not like doing it their way, but you have to understand how to do it, because you may see that on any of your book tests, NWEA, or ISTEP tests. Here's the information, fill it in correctly. So if I know that the area of each face is, and I look at it, it's a cube because I have 2 by 2 by 2. So I'm going to take 2 times 2, which is my base times my height, or my length times my width. I know that each of them are 4. Well, the number of faces that I have is 6, front and back, top and bottom, right and left. So if I take my 4, which is my area for every single one, and multiply by how many there are, I know I have 24 square feet as my surface area for this cube. When I go down here then, I have number 2, a triangular prism. So I know I have to do more math there. I can't just do the triangle effect because it doesn't set up correctly because these are all different lengths. So we're going to start with the triangles. I know the triangles are base times height divided by 2. And then I plug in the information that I know. I know that I have my base and height of 8 and 6. And that goes for both of them. So 6 times 8 divided by 2. And 6 times 8 is 48 divided by 2. And then I type in 48 divided by 2 is 24. Because there's 2 of them, then I have to know that I have to double 24, which takes me back to the 48. So I know that my triangle areas are 48 square centimeters. I keep that, and then I go on to my 3 different rectangles. The triangle effect doesn't work because all of these measurements are different, so each rectangle has to have a different length and base. So I go to the base and height, of the first one. So I'm going to take my 16 times my 10. 16 times 10 gives me 160. I don't have to do anything else because it is a rectangle. So I'm going to add that to my 48 that I started with my 2 triangular bases. Then I'm going to look at 8 times 16. 8 times 16 gives me 128. Type it into your calculator. 16 times 8 equals, I see it's 128. Once again, a rectangle. I don't do anything else to it, so I know I'm going to add that. And then my last one takes my 6 and my 16 for that back side. So 6 times 16 tells me that I'm going to have 96. When I type it into my calculator, 96 plus 128 plus 160 plus 48 equals, then I know my surface area of this triangular prism. The triangular prism, once again, because the ends or the bases are triangles. Then I get 432 square centimeters. The number 3 then, I'm going to use the triangle effect. Now I'm hoping in your workbooks that you actually have the numbers, because when I took this offline, it didn't have any numbers or labels on it. So I had to come in and look at my teacher's edition to find the numbers. If you don't have the numbers in your workbook, then please write them down. At the bottom for the base we have 3.5. And then the width for the bottom is 4. And then the height is 8.5. And I believe it's a label of inches when we get to the answer. So because it is a rectangular prism, I'm going to use the triangle. However, I have to realize that I can't use mixed numbers in a multiplication problem. And I know I'm going to multiply because since they're rectangles on binary, it's always base times height. So I have to convert that or change that into an improper fraction before I begin the math. Once again, I take my mixed number and I start at the bottom and I'm going around, I multiply and then add. So I'm going to take 2 times 6 or 8, which is 16, and 8 plus 1, which is 17, and I'm going to keep my denominator. So 2 times 8 is 16. 16 plus the 1 is 17. That's my new numerator, and I keep my denominator. So this is 17 halves. Then I'm going to change the bottom one, 3 1/2 also, and I go to the bottom, multiply and add. 2 times 3 is 6, plus 1 is 7. Keep my denominator. So I know this measurement is 17 halves. And then because I'm multiplying, when I get to the 4, I'm going to put 4 over 1 because I have to have fractions. I can't have whole numbers and mixed numbers. So I set up the triangle, and I multiply them in groupings, and then I always double it because it is a rectangular pyramid. So 17 halves times 17, 7 halves times 17 halves gives me 119 fourths. I'm going to keep that for quite a while and just work with that until I get ready, until I know if my other denominators match up or not. But when I double it, I know that I'm multiplying by 2. And once again, I multiply every one of these by 2 because there's 2 sets in rectangular prisms. It makes my life a little bit easier because I know I'm going to just simply cross-reduce those. When I multiply a denominator of 4 by a whole number of 2, I could just cross-reduce it and get rid of that 2, and that becomes from a 4 to a 2. So I have 119 halves, and once again I'm going to keep that until I get to my denominator of my other fraction numbers and see if I need it or not. I'm going to look at the 4 over 1 times 17 halves then. I'm going to multiply those, and when I set it up, I have 17 halves times 4 over 1. I have to put whole numbers over 1 when I'm multiplying by a fraction. I can cross-reduce, and 2 goes into 2 once, and 2 goes into 4 2 times. And then I just multiply across. All I'm left with is 17 times 2, and 17 times 2 is 34. 34 has to be doubled then, because there are 2 of them. So once again, I always multiply the 2 together, and then I double them because it's a rectangular pyramid. 68 then is going to be added to my 119 halves. Then I go to my last grouping. I have 4 over 1 and 17 halves, or 7 halves. So I have 7 halves times 4 over 1. I know I can cross-reduce the 2 and the 4 again, because they're even numbers. 2 goes into 2 once, and 2 goes into 4 twice. I'm left with 7 times 2, which is 14. Once again, multiply the loops, always double them, so my 14 has to be doubled and changed to 28. So that leaves me with that addition problem, and none of the other ones have fractions, and I don't have to worry about multiplying. So I'm going to go ahead and change my 119 over 2. And what is a fraction telling me mathematically? So hopefully the word division popped into your head, or maybe you even spoke it out loud, because we need to know that fractions are always telling us to divide. So when I divide to solve for what is 119 halves, then I put my top number inside my division box and divide by 2. 119 divided by 2 is going to give me 59 and a half. Now, here's what the I-step is going to expect from you. It started out with fractions. They're going to expect your answer to end with fractions. I'm going to tell you also, it's best to end with fractions just so you don't forget that on the I-step test or the NWEA that you're going to take this week. But in all honesty, when you type it in to your calculator, you do your math and you end up with 59.5. I know it's the same thing. I'm not going to count it wrong if you put it as a decimal. So 59 and a half or 59.5 is workable. But then what do I have to do in order to get those all together? Stack them up, right? So I'm going to stack them up either with the decimal 0.5 or like I have it here with the 1/2 out to its side. The 1/2 plus nothing is just 1/2. I don't have to really worry about it because it's addition. And then when I add these whole numbers together, I get 155. So my answer for number 3, after all that work, 155 and 1/2 square inches. Once again, this is not difficult math. It's remembering how to multiply, sometimes how to multiply with fractions, how to add things together, sometimes with decimals, sometimes with fractions, or just whole numbers, and remembering the steps. Remembering to find the areas of every single shape that makes up the 3D item so that I can add them together and get my surface area. All of the outside added together. So we have 3 more that we're going to work, and then the lesson will be yours. I have 3, 5, and 8. So I'm going to do my triangle effect once again. I'm going to set it up. I have my 3, I have my 5, I have my 8, and I have them all looped together. Remembering to multiply my loops together and then doubling them because it is a rectangular prism, so they always get doubled. So when I take my 3 times 8 at the bottom, I'm going to then double it. And 3 times 8 is 24. 24 doubled is 48. So I know my base set or my base pairing is 48 square meters. When I go to my red, I have a loop of 3 and 5. When I take 3 times 5, I get 15, but I'm going to double it. So you see that I put in parentheses the 3 times the 5, and then it's doubled times 2. So I have 15 times 2, which tells me I have 30. And then my last one, the blue that I have, is 5 times 8. It's going to be doubled. So 5 times 8, or 8 times 5, as I have it there. Doubled, I have 40 times 2, which is 80. To find the surface area, all the areas together of those faces, I just add them together. So I have 48 plus my 30 plus my 80. And I know when I add those together and I type them into my calculator, I get 158 square meters. Once again, label has to be squared because it is an area problem. But number 5, for my cube, I have 7.5, 7.5, 7.5. So I have to take my 7.5, I have to change it into an improper fraction. I go to the bottom, I multiply, then I add. 2 times 7 is 14. 14 plus 1 is 15. I keep my denominator. So I know I'm going to have 15 halves. So when I look at setting that up then, as the book showed you, if I take my 15 halves times 15 halves, that gives me my area of one face. 15 halves times 15 halves. And then my number of faces is 6 because it's a cube, it's a rectangular prism. I know I have a top, a bottom, a front and a back, a right and a left. So I would then multiply it by 6. So one of the things that I saw the book show you a couple weeks ago, I'm going to do that here so you understand what it's saying. When I have a fraction times a whole number, the first thing I have to remember is that whole number is over 1, isn't it? So if I multiply across, my denominator just becomes 4 because I end up with 2 times 1, and I'm going to put a 4 down there. But then all they're doing, instead of multiplying these 3 together, they're showing you that these numerators look like this. If I actually go ahead and multiply them together, which I will in just a second, it would end up with a whole number over a 4. So if I show that I'm just keeping my numerators, that's all the book was trying to show you a couple of weeks ago on that lesson. Those numerators stay the same, and I see that my denominator is 4. Then I multiplied my numerators. So when I take 15 times 6 equals, I get 1,350. It's a big number. Wouldn't expect you to be able to do that mentally. I don't do that mentally. But then I have my denominator of 4, and once again that mathematically tells me to do what? Divide, right? So inside my division box I have 1,350 divided by 4, and when I divide it through, I get 337 1/2 square inches. Once again, if you end up with an answer of 337.5 square inches, I'm not going to count it wrong, because 335 or 337 5/10 is the same as 337.5. It's still the correct answer. So the last one that no, that was it. I apologize. So going through this lesson again, it's not the new math because we've done this for 2 lessons. We did all of areas for the previous 9 lessons, 8 lessons. We skipped chapter 8 of chapter 10. It's not difficult. So please don't say, well, it's just too hard. It's not hard. It is a lot of work, and you have to be willing to put forth the effort in order to do well. This stuff doesn't go away. This stuff is stuff that you're going to carry on doing for the next 3 years of school. You have a half a year here, but you're going to do geometric shapes and areas and surface areas from now forward. When you get into analytical geometry, which is a higher math with trigonometry, you do geometric shapes and you have to know how to do these. But you do it in 7th grade and 8th grade. So it's not one of those things that you can just kind of wing it and then you'll be successful in 7th grade. I need you to understand this. So what we're doing is we're always finding a base and a height of our shape, and then we're going to double it. If it's a pyramid, rectangular pyramid, or a cube, then I can do my triangle. My triangular pyramids, I have to find the area of the bases, and there are 2 of them because they're triangles, but then I have to find the individual areas of the rectangles that make up the flat faces or the lateral faces. So if you didn't understand something, please go back and look. It's a shorter video, I get it, and it shouldn't take you long, especially since we also did this on the last lesson, which was 11.2. But please come and ask questions if you have any. If not, then you can go ahead and get busy on your homework, or you can start on the extra credit projects which are due on Friday.